Okay.
You're good.
All right, we're going to get started then. So thanks very much. We had a really interesting day yesterday, and we got a lot of the theoretical stuff out of the way. So what is converged cloud? What is cloud? What's our bigger, broader cloud portfolio? We talked about had a software piece, we had a cloud system piece, we had a converged infrastructure piece. So yours is the first session of the second day, talking about software. Yesterday we talked about OpenStack. We talked about how all these different elements fit. So again, I'm really looking for you guys to continue to broaden the cloud story, how the software fit. We talk about it as a stack underneath a converged cloud, underneath a converged infrastructure platform.
Storage.
Yeah. Okay.
Software. Or storage, not software.
Yes, Calvin.
So
storage.
Calvin Zito over here, for those who haven't met Calvin, probably the most prolific blogger I know, social media guru. Patrick Osborne, I'm thinking in the middle. Patrick Osborne.
And Chris Purcell.
Okay, all right. All right, we've taken enough time. We'll get started.
Great. So my name is Patrick Osborne. I'm Director of Product Management within the HP Storage Division, and I also have with me one of my really close colleagues that we work with quite a bit is Sam Feinberg. He's a distinguished technologist in the office of the storage CTO. So, as we say in Boston, he's a wicked smart guy. So we're going to talk today a little bit about cloud storage and what we're offering from HP and how we fit into the converged cloud. It's funny that Chris actually said we're going to talk about software, because at the end of the day, it is really a lot about software. We are fundamentally a software development organization, and when we talk about purpose-built appliances and software-defined storage, it's the lines are definitely blending. So one of the things that we've been doing here with HP storage is we made some significant acquisitions over the last few years, which has bolstered our portfolio of storage. Right, predominantly one of the biggest ones we made in the last 3 years is 3PAR. And this type of technology has enabled us to have one architecture for people scaling from the mid-range all the way up to very large service providers and people that are doing IT as a service. We've made some significant acquisitions in the space of left-hand networks, right, which is sort of one of the first software-defined storage companies out there, as well as I actually came from iBricks, which is a scale-out NAS and a scale-out object platform. So we got some things in the space which people are using to enable cloud storage, and we'll talk a little bit of how that all fits together. Fundamentally, one of the things that we talked about. Did you guys see any of the plugins for the 3PAR StoreServe platform and talking about any of the technologies yesterday? Virtual system, cloud system.
Don't let me down. Don't let me down.
Yes.
Yes.
Yes. And so who's familiar with the 3PAR architecture and HP storage? Yes. Yeah. Okay. So we got some people in there. So really, what we're doing is we're able to provide a platform that gives folks some key capabilities around. Obviously, scalability is one. We have one architecture that scales up from the very low mid-range up to very, very high end. And this enables customers to start very low, stay with one architecture. We are able to use this in service providers. We've got some of the biggest service providers in the world that are providing cloud services built on top of the 3PAR architecture, folks like Savvis and other pretty big providers. But some of the key capabilities that we see in the space are around federation. So we're able to federate workloads in between, one system, multiple systems. Oftentimes in the cloud, a lot of the workloads are very unpredictable from a compute standpoint, and that definitely applies to storage. So being able to fundamentally federate services for storage, LUNs, bandwidth, IOPS, front-end connections, and move those around in between a federated, active mesh controller architecture is very important to our customers. Efficiency is huge in the cloud world for storage. So being able to not having to over provision storage is very key, right? So in a normal sort of siloed data center, you're putting capacity on the floor and setting a bunch of it aside, whether it's 100 terabytes or less for a database application or whatnot. You really don't have that sort of luxury in the cloud world. So with a lot of things that we have around thin provisioning, thin persistence, thin reclamation, we're able to become very, very efficient to the point where actually we guarantee this for our cloud platforms. We have a get thin and a get virtual program that allows customers to double the number of VM density and virtualization. We also have this get thin, which will allow you to reclaim 50% of your storage space right off the bat if you upgrade an architecture service around a 3-part platform. So we're all about efficiency in this area as well as multi-tenancy. So one of the big things, the reasons why this architecture has been so popular with service providers and people doing cloud, private cloud or IT as a service, is it's multi-tenant. So in addition to having this active mesh controller architecture, the federation, and all the efficiencies, being multi-tenant in this area is very key. So we're able to support and create a number of different storage zones on an array or a set of infrastructure that allows you to have separation of quality of service, IOPS, and obviously security is key. So for us, this is a platform that you'll see it's embedded with things like Matrix, the cloud system, when we talk to our customers. And when we work with other folks within HP, right, on our public cloud services, this is the type of infrastructure that they're using as well, right? So we have two very large public cloud offerings. We have hpcloud.com and we have Autonomy, right? Autonomy is one of the largest data-centric clouds in the world. It's in upwards of 100 petabytes of data in the Autonomy cloud for everything from sync and share and collaboration to specific things around e-discovery and legal, as well as we have an hpcloud.com service that provides you with a couple different things. It provides you compute, as well as a block service, in addition to an OpenStack Swift-based object service. You can create your own account, scale that up with a credit card, and you're off and running. And those services use these type of architectures. So at the end of the day, HP Storage is in the business of creating products and solutions that our customers can use to enable their infrastructure to do IT as a service, as well as we're selling to service providers. Our own internal, we're so-called eating our own dog food, and as well as talking and selling and architecting our solutions for other major service providers, folks like Savage, British Telecom, different folks of that nature. So some of the key things that enable us in this space are provisioning, right? So automation, control, from just a dollars and cents standpoint for gear that you have to acquire and put on the floor. We have those federated and efficiency features. One big thing is that that you guys have seen probably from your customers is that efficiency can also be gained through headcount reductions or being able to have more petabytes managed per storage admin. So one of the things that is really big for us in the 3-part area is that you're able to support and administer this platform with very few resources. It's autonomic in a lot of cases, and one of the things that we are marching towards is full provisioning and automation that plugs into things like cloud system. So for us, we are embarking on a multi-year, multi-quarter initiative around making all of our storage products extensible through APIs. So the Web Services API provides like a publicly available, well-known, published programming interface to do your everyday storage administration tasks. So what we're trying to do is cut out inefficiencies, that you can automate this and put this into a lot of provisioning tools and provisioning workflow. So tasks that we support are, creation and removal of CPGs, which are, groups of LUNs, and as well as just virtual LUNs and being able to carve out LUNs and add capacity and zone that. being able to take a look at how much capacity is used for a given LUN, or how much capacity you're using for a group of a group of data per customer. So you guys can, if for the techies in the room, if you want to go crazy and take a look at the SDK and the developer's guide, this is something you're going to see more of for all of our products, and this is one of the reasons why many of our cloud providers really love this platform. Okay, so does anyone have any questions on automation or APIs? Okay. So in that vein, we are designing some of our things, some of our solutions that we've built here to be purpose-built, hardware and software solutions. So we've got on the primary storage side, tier 1 for virtualization and IT as a service, providing block, object, and file services for basically primary storage use cases, on-premise as well as cloud providers. In the bucket of information retention and information protection, we've got some really great industry-leading solutions in Store All and Store Once. So you've got sort of hyperscale storage to help you store a lot of unstructured data, as well as Store Once to help you protect it and deduplicate that data. And we've taken some of the technology, and you see on the left-hand side, we have a huge partnership with HP Labs, 3PAR, iBricks, Left Hand, and melding those together to bring some unique things to the market. So one of the themes that you'll see throughout this past year and then throughout this year into the future is this whole theme of software-defined storage. So those big boxes behind it, we have purpose-built solutions, right? So you can buy an array and deploy that today and for primary storage. We have a software-defined strategy as well. So that is server and storage agnostic. It's scale out, and our goal is to be hypervisor independent as well. Because a lot of people are drawing lines of VMware versus KVM versus Hyper-V, and then OpenStack has gotten some press recently around replacing some VMware environments. So we want to have a software-defined strategy, and we've already delivered on one pillar of that, is software-defined storage for primary storage. So we have the HP Store Virtual. We have probably about 150,000 downloads of this and unique customer implementations. And what this allows you to do is, in a hypervisor, you can spin up N number of virtual machines that run Store Virtual, and it becomes a scale-out iSCSI cluster for you. So for customers that are looking to, cloud customers that want to provide a pretty high-performant, low-cost, elastic iSCSI block service, that's what you have for Store Virtual. And if you take a look at the diagram, you can kind of imply of our direction in terms of providing similar software-defined storage appliances throughout the future as we march along this path. So there's some customers, that want to buy purpose-built hardware appliances from HP that are specifically tuned, and they work for a specific workload, and they provide hardware and software combined. We have other folks that want to provide this type of service, but for software only, right? So we are, we're marching down that path, and we're going to support customers, and they're, they want to be open.
There we go. We're clear.
Yep. In terms of transforming the industry in terms of converged storage, I just wanted to talk a little bit about some of the technology pieces and how they fit and where we're addressing some needs around cloud storage. So you hear a lot about block storage and file storage and object storage, right? They sort of come from the bottom up in terms of geographic latency and proximity to who consumes the storage at the end of the day, right? So for block storage, this is a protocol that's built on primarily fiber channel. You have options for SAS and iSCSI on IP networks as well. But for the most part, this is a protocol that sort of has a data center proximity, right? You have hosts. They could be bare metal hosts, connected via fiber channel cards. They could be virtualized hosts talking over, let's say, a 10 gig, V network, to an iSCSI interface. But for the most part, data center proximity block, you have, a LUN is mapped to one host or a smaller group of hosts, right? Serving up pretty high performance application data. As you move up the stack in terms of latency and proximity, you're moving into the world of NAS, right? So network attached storage. Some of it's scale up, some of it's scale out on options like we have a store all. But for the most part, NAS is, SIPs, SMB, and NFS. There's also options for HTTP and FTP protocols, but it's usually like a local and wide area proximity. You have a NAS share that's being consumed by a group of clients. Could be servers, could be laptops, things of that nature. One of the new paradigms we're seeing is the internet proximity scale, right? So is this notion of object storage, right? Which moves from NFS and SIPs share path names where you'd have like slash file system slash Patrick slash foo.txt. You're moving to actually IDs and metadata, similar to what you'd have with something like Amazon S3, for example, right? So you are using fundamentally REST-based web API methods and using the REST protocol, which is very latency tolerant. So moving towards internet proximity, and a lot of this is actually programmable storage, right? So instead of using a file system taxonomy or a fiber channel world, this is moving to programmable storage for the most part, right? So you're moving from files and path names into GUIDs and metadata and accounts and buckets and objects. And that's usually getting consumed by applications, and you'll see a lot of things in this world around enterprise sync and share and things like that. So we collaborate with HPCloud.com has a publicly available object service, and we mirror some of the same APIs that we provide in our on-premise storage solutions. So if you think about it, you've got store all that provides object API interfaces that you can have inside your data center, or you can have a publicly available cloud storage service that's outside your firewall and accessible on hpcloud.com, giving you the same experience for provisioning and data access. So for us, it's all about convergence, even in the product lines, as well as on-premise versus off-premise. Okay, so I just want to show you guys that. This is some cloud storage 101. I'm not going to go through this. I kind of talked through it, but you guys are available. These slides are available for you if you want to take a look at it. It's pretty much the difference between block, file, and object, and where some of this stuff is going. Kind of talked a little bit about some of the store virtual software-defined storage, but at the end of the day, we have a lot of customers and service providers implementing this right now. So huge enterprise servers, huge enterprise customers that are looking to leverage, simple scale-out iSCSI interface. It's very scalable, non-disruptively. You can scale from a 2 or 3 node cluster to a huge cluster moving into the petabyte range in terms of capacity. It's very highly available. It lets you do multi-site SANs. But one of the most important things is it allows you to, if you install the software-defined, the VSA, our virtual storage appliance, it allows you to capture, to take captured capacity that's within a hypervisor and expose that as, an available, scalable iSCSI service. So if you have numerous hypervisors that sit in your data center, and each one of them, let's say, has 100 terabytes of capacity behind it. If you're running at, let's say, 30% capacity efficiency, you have a lot of actual storage capacity that's locked to that specific hypervisor. What's interesting for our customers is to be able to take these VSAs and install them across multiple hypervisors, take that captured capacity and present that as a service, globally. so that you can have a huge data plane for, in this case, iSCSI. In the future, it'll be other services. So this is a huge thing for customers, especially service providers, to increase their efficiency, which is, it's all about a pricing game and SLAs at the end of the day, right? So this is a, sort of a breakthrough technology. Like I said, Store Virtual can be bought in sort of a purpose-built appliance mode, or you can get it in a VSA, and we've got 150,000, customers doing VSAs today, and you'll see some partnerships.
Hey, Patrick.
Yeah.
One thing worth pointing out, if anybody wants to play with a VSA, is that it is available as a free download, that you can get a full-featured 60-day trial. The URL is hp.com/go/try VSA, and it's something you can run on any hypervisor that you have and run the full-featured trial. So it's something you definitely can download and play with yourself.
Yeah, I would definitely highly recommend it. It's super easy to install. So if you download it, it comes in an OVF file or whatnot. You can boot it up on your hypervisor. It's got a pretty slick interface to get that up and running fairly quickly. Integrates right into like your VMware environment for an iSCSI service. So you can do that, stand up some compute instances right next to it, attach your storage, and you're off and running. Okay.
Can you say the web page?
In terms of object storage, we are seeing a lot of customers in the cloud area move to object storage, right? So you have some options that are commercially available. You have some open source alternatives in the world of object storage, right? So what we've done is with StoreAll, we're providing a converged experience for customers doing file and object, right? So we have a very scalable solution for StoreAll. It starts at 2 nodes and scales up to 1,000 nodes. It scales capacity-wise in a single instance up to about 16 petabytes. So we have customers that are building services based on top of this, backup as a service, disaster recovery as a service, just storage of unstructured data for their end users. But the key thing is that it's providing you 2 different sets of protocols. It's giving you scale-out NAS, so file-based protocols, CIFS, SMB. It's also providing you with an object and REST API for data access as well as provisioning, with a whole full-featured set of data mobility, management, data protection features underneath it, with very scalable dense storage underneath. So, we can put about 1.5 petabytes in a rack, right, in a standard HP 42U rack, and scale that out horizontally. So we have some pretty significantly large customers that are building something as a service, that are deploying on top of this, moving today from file, which is sort of the predominant protocol in some of these areas, moving quickly into object, right? So we have our own internal customers using things like that. I don't know if you guys use Snapfish, for example. They use this technology. They have well over 50 petabytes of storage up in the cloud today, and we're capturing other folks very rapidly in the space. So now I'm going to turn it over to Sam to talk a little bit about some of our directions in OpenStack. We are clearly in the OpenStack swim lane at HP. We are one of the biggest providers of code from an enterprise company into this initiative, and for us it's very strategic. So Sam's going to talk a little bit about OpenStack environment, where we're plugging in, how that's working for provisioning, and before I turn it over to them, if you guys have any questions on the stuff that I've presented, feel free to jump in, or we can move on to Sam.
Okay. Any questions from you guys?
I think we're good.
I think we're good.
Okay. So, as I'm sure you've been hearing all week, HP's taken on a big commitment to work with the OpenStack community and to provide technology for OpenStack, and our storage group has been doing so as well. We've been, particularly what we've been able to deliver today has been quite a bit around our block storage. We have probably more going on in the object storage world as well, but that hasn't made it out yet. So go to the next one. So the big piece we've done in block storage is we've been working with the Cinder group, which is part of OpenStack. OpenStack uses block storage for boot volumes. So anything that a virtual machine boots off of can be used based on Cinder storage. It's also it also can be used for additional storage volumes if you need to have more space to put an additional file system on. If you need it for a database, that would be allocated as a volume using Cinder. The Cinder volumes can be allocated to any virtual machine in an OpenStack cloud, but they're not necessarily shared at the same time by two virtual machines. So Cinder was originally a piece of the compute environment, which is called Nova. It was originally named Nova Volume. It was broken out in Folsom, which was the last version of OpenStack, the one that came out last fall, into this separate piece called Cinder. Cinder was the first version of Cinder was pretty much just a version of Nova Volume that was separated, but it more recently, in this new release, Grizzly, which should be released any day now, we've started adding additional features to it beyond what was originally in Nova Volume. And in short, really, Cinder is a plug-in model for managing block storage volume. So you can plug in lots of different kinds of storage, different companies' storage. There's support for anything from running block storage on top of NFS volumes to people's complex storage arrays, or 3-par arrays, for example, which I'll talk more about. Next one. So one of the first pieces that we did in Cinder was one of the original. There was actually a driver already in OpenStack. It was one of the original pieces in Nova Volume, supporting the left-hand storage product that HP sells. This original Cinder driver was contributed by Rackspace. We actually hadn't written it ourselves, and this was part of OpenStack almost from the beginning. What we've done more recently is we've taken the code base back, and we've started contributing an updated version of it. We updated it to make it work with our current versions of our Store Virtual product. So we fixed some bugs that were already reported in the open source community, and we of course contributed all that code back into the Cinder code base. You can get a version of this was in Folsom, and if you pulled the development release of Grizzly, you'd see that we've contributed this back as well, and this will of course be part of the official Grizzly release. And this version of the iSCSI driver is actually used in quite a few places, including Rackspace. More recently, we wanted to have support for our newer storage products and for our dedicated storage array, the 3-par arrays. So there wasn't a Cinder driver available for 3-par, so we actually took it on to create that ourselves. This piece was put together by one of our management software group. It implements all of the major Cinder API functions, and this was pushed into the Grizzly release a few months ago, and should be part of the official Grizzly release that comes out in April. So the bigger piece that we've been working on is when we were at the last OpenStack Summit back in October, we talked with several companies that were doing block storage and for the cloud. And we saw that we saw both in our customer base and also in other companies that were working with OpenStack, there was demand to not only use iSCSI, but also to use fiber channel storage in these cloud deployments. We actually, in order to get that to happen, we got together with people in several companies that were working on both OpenStack and on fiber channel storage. The list of companies is above. And we put together a blueprint for adding fiber channel storage support to, you had to add it to both Cinder, and as well as there was some support pieces that had to be added to Nova, which is the compute environment as well. We did that. We created the code to do this, and we recently were able to get the code released into Grizzly to do the our phase 1 support for fiber channel. The current fiber channel release supports only pre-zoned or open storage area networks. It doesn't have the ability to actively zone the fiber channel network. But that code is already in the Grizzly development stream and will be part of the Grizzly release. We will have, I'll talk on the next slide, we are also working on an active zoning piece that'll come out later. We also, in order to support this release, created a fiber channel driver for 3PAR. So there's a Cinder driver that works along with this fiber channel support to allow you to use to allocate fiber channel storage for OpenStack volumes. It works just like the iSCSI support, but it works over a fiber channel network instead. Go to the next one. The next piece that was part of this project we were working with these other companies was we wanted to have support for more active zoning in fiber channel networks, being able to have different SAN configurations, being able to dynamically zone the SAN so that you would have better partitioning and security within the fiber channel network. And this is something we're actually working closely with Brocade on, and the code for this is, we've already had the blueprint accepted for this, and we're working on the code right now to get this support into the next release of OpenStack beyond Grizzly. So this should hopefully be in what's called the Havana release, which is the one that's coming out in October. The next one. Another big piece we see coming along in block storage for OpenStack is the ability to support what are called volume types. So when originally the block support was created for OpenStack, all block storage was treated the same. You could, if you had, no matter what, whenever you wanted a volume that was a particular size, it would just allocate whatever storage was available. What we want to do is we want to have the ability to differentiate between different types of storage. Maybe differentiating between something that's on an iSCSI volume versus a fiber channel volume, or on a store virtual system versus a 3PAR based system, or maybe it's a volume that's on solid state disk versus one that's on physical disks. And we want to be able to have, when you allocate a volume, be able to give a way of telling it that this is the type of volume that I want provisioned, as opposed to just any storage that's available. This capability has been something that's been getting worked on in the Cinder groups for quite a while, and we're hoping to have full support for this in the Havana release of OpenStack, and have the ability to use this to expose the capabilities of our storage products. Okay, so those are the specific slides that we wanted to go through. I was hoping we could get some more questions about what we're doing in cloud storage, what we're doing in our storage products specifically.
Oh yes, my name is Omar Sanchez. I'm a local blogger here in Puerto Rico. Nice to meet you guys.
Pleasure. Thanks for coming.
Thank you. This is the third time I've been here. Never been in the Halo before, so thank you. I have two questions. The first one is
we'll
for.
We'll sell you one for your house if you want one.
That would be lovely.
Yeah, it will be. You guys, are you guys working right now with health department, health any Medicare or Medicaid projects or anything related with health using OpenStack? Any EHRs, anything from data storage for health systems? Any APIs from health systems?
I mean, we've got a pretty good partnership in that space, but usually it's more like on the vendor side. So we work a lot with EMR and PACS vendors, and then work with specific customers. Most of the time they're hospitals or hospital groups, or in the case of some other countries outside the U.S. Institutional health.
But as far as compliance, which it's my question, how do you guys meet the requirements for electronic health information interchange with your SAN servers? What kind of stuff they ask you to provide for security?
Yeah, so I can tell you off the bat, most of the stuff from a security standpoint will not allow you to store any of this data off premise, right? So first off, in most countries, that data is not portable. That needs to stay on premise within the data center for the most part. So there's some security rules. Some of the things that we get around that space are auditing, for example. So being able to audit who's accessing which files and what. We have some specific technology we use in StoreAll to produce audit logs and security functions. Some of the other things we get is around encryption, right? So self-encrypting drives, encryption of data at rest, for when you back up that data. So those are some of the requirements we get. A lot of that stuff happens at the application level. So if you're doing EMR and specifically PACS, like you take GE Healthcare or AGFA, for example, they have specific security features built in. So a lot of that stuff is taken care of at the application layer.
So nothing cloud with EHR for you guys right now?
Not right now. There's so for us in the U.S., it's governed by HIPAA. There's some pretty stringent policies here as well as in Europe about the data portability for those type of records. So unless it has to be enacted by the specific user to take that data, and it's usually given to you on like a CD, at the end of the day, So around those specific environments, we're not seeing a lot of collaboration per se in the cloud, just because of the regulations.
Yeah, for the sharing of information and stuff. And what about? And you guys talk a little bit about the duplication systems that you guys. What do you manage there for the duplication?
Yeah, so we have some pretty interesting technology with Store Once in terms of deduplication. So it's developed in concert with HP Labs, so we've got a long history of innovation there, as well as a long history of innovation around tape products. So we've taken some of those algorithms around, like LTO compression and encryption and that kind of stuff, and evolve that into a software scale-out system called Store Once. So for purpose-built backup and archiving, we have a very scalable, extremely fast solution. It's fast for backups, but it's even faster for restores, which is the most important, right? And it's extremely efficient with the dedupe algorithms that we use. So we do that.
We've recently added the capability to scale that out, so it can be actually clustered you can cluster together federate together multiple Store Once servers, and it's a technology that was actually developed. I think Patrick mentioned this, that it was developed originally at HP Labs. It's all internal technology, and it's something that we've actually developed from the algorithms themselves up to the actual product.
Yeah, we actually see a lot of we're getting a lot of traction in that space, partnering with. We have some solutions that are all HP driven, so with Data Protector and plugging into the hypervisor and using Store Once. We also have some pretty good traction with providers like Veeam, for example, for backing up virtual machines and designing pretty much like either a backup plane or a backup as a service, plug into cloud environments. And we're using this type of technology internally as well on some of our cloud, right? Because we have backup is an interesting topic. It's a service that's rife for moving outside of your data center, right? So we have, from a backup perspective, we have some unique technology in autonomy, specifically Live Vault and Connected. I don't know if you're familiar with those, but what we do is we actually design systems in HP storage with the Live Vault and Connected services embedded, so that they are like the minute you turn them on and put data on them, they're protecting. So if you don't have a backup service that you have and you're a smaller company, then you can use Live Vault for that, right? So we are providing some things that are scalable from a technology standpoint, so you can design your own service, but we're also partnering with the folks in autonomy using Live Vault and Connected, and you'll see some directional things coming out later on this year in that area as well.
Electronic Vault it's been with HP for how long? For backups?
Live Vault?
Yeah. How long you guys been?
Yeah, so that was part of the autonomy acquisition.
Okay.
A couple years.
The service was.
Yeah, it's a backup as a service.
Yeah.
Okay.
Yeah, and we actually use. So you think about HP and Calvin. What's our employee count now? North of
300,000.
Yeah, 300,000. So we have, so on my laptop that I'm presenting on right now, I'm running Connected, right? So we have, from an implementation standpoint, it scales, right? So we have a service that's, built and managed by autonomy, and we use it to back up all the data on our end user devices. So it's, from an enterprise, scale level, it definitely scales. We use it on a daily basis.
I mean, we've also had backup technology for the enterprise for a long time. The Data Protector product, which is now working under autonomy, but it was originally an HP product. Has support for our deduplication embedded in it. It also has the ability to do target side deduplication. And it can also have a software deduplication engine that's based on the same Store Once technology that we use in our hardware deduplication storage products.
Yeah, which is important. So you can choose to dedupe at the client side, you can dedupe on the media manager side, you can dedupe on the device manager side. So this is actually, the deduping on the client side is actually pretty popular in the hypervisor architecture.
Can you manage the duplication using infrastructure as a service or not?
I don't understand your question.
Well, if you're going to manage yourself, if you have your infrastructure as a service, can you acquire APIs for deduplication or deduplication management?
Yeah, so the dedupe framework for Store Once, we have a whole set of APIs there. It's called Catalyst, right? And it allows you to plug in those specific dedupe libraries that Sam was talking about in different layers of the stack. And then, so we make it available we integrate, obviously with Data Protector because it's our own product, but also plugs into other industry solutions like, Net Backup, Backup Exec, things like that. So it's an open standard API that we have published, and you can manage it.
You say it's called Catalyst?
Catalyst.
Yes, Catalyst.
Yeah, Catalyst.
But that's still within a single client or single customer. When you start moving into multi-tenancy, that the whole deduplication problem becomes more complex, both from a political but also from a technical perspective, right? Because you have the security paradigms as well as just the management across clients. Sure,
because if you want to dedupe at scale, you want to get as much data that's repeatable, right? But that means you could be it's the thing is, it's the choice to encrypt before you dedupe or encrypt after you dedupe, and how much data you can have access to without compromising security. So it's definitely a technology challenge.
Well, you have that problem within one client. But if you take that problem and then you complicate it by multi-tenancy, right? You can't do dedupe across clients today. I mean, technically you could.
Yeah, I think that's always been a security issue, because you kind of have to decide whether you're willing to have clients know whether other clients have the same data. And so if you're using the same set of encryption keys, that's an issue. So it's been a challenge that I've seen handled in lots of different ways. I think that, the interesting thing is that when you start looking at where you actually get deduplication, there's certainly common data between that you see in terms of system files and so forth between different customers. But if you're talking about actual content or database, entries in a database or files that people have in their user directories, it's very unlikely you're going to see deduplication between those anyway. So it really, your biggest benefits you tend to see within tenants anyways.
Any other questions in terms of the publicly available cloud storage services or any of the technology that we're developing within HP Storage to enable those type of services? You guys have?
Well, concerning the data duplication, you do that on your servers. I mean, you provide the servers for the cloud system for a lot of customers, and you have to back up all of that data. You do it on your sites because that's a huge amount of data.
Yeah, so some of the services do and some of them don't. So like for example, within autonomy, some of the services will do single instancing and deduplication on the back end, and some of them do not. And it's usually depending on the type of service. Like e-discovery and legal, retention, for example, will not do that. But I think connected, will do that at the back end. So it's kind of service dependent. I can probably get a list of some of those and how they're architected if you want. But it's one of those it depends answers.
Okay.
What other questions? Anything else you guys have top of mind?
Did you guys talk about like cloud futures? I've been in and out, so I don't want to ask a question, but if you want to, where is storage heading to? We talked about everything almost like application, software driven, these kind of almost like these plug and play modules. Do you want to?
Yeah, one of the questions that I would have is, beyond kind of the block and tackling in storage management or data management, for years now we've had the opportunity to do data migration, right? I forget what the analogy or the acronym is. It's like SRM, or it's where you can start to age data and have certain policies around the aging of data and what you do with it. But I think, I guess the question I have is, how sophisticated is that? Are you able to take that today and maybe into the future? Because I would think there's a huge opportunity around just the intelligence that you could build into data management algorithms beyond just the basic block and tackling of aging data and moving data between different types of storage resources.
So one of the things that we kind of went over quickly when we were talking about 3PAR, and one of the things that makes it a compelling story in the for these kind of service provider environments is because it's got 3PAR actually breaks data up into what they call chunklets. It's very small pieces, and all of those pieces can be treated as can be tiered between different types of storage. It's used to distribute the load over a very large number of devices. So one of the key technologies there is that you can provision a volume that is provisioned in one way when you start, But when you start to see that these certain pieces within the volume are more or less used, those will either get moved to something like a SATA disk if they're not used very much, or they'll get pulled to SSD if they're used a lot. And this can all be done at a very small level that's much smaller than the size of a particular volume. It's all at the sub-1 level. And so that way it can dynamically adjust, both whether storage is allocated. If it's a 0, it can actually deallocate the storage, or it can figure out this is a heavily used piece, this is a not heavily used piece. If that changes over time, it will adjust the storage to be able to deal with that. And we're also looking at, even within our primary storage, we're looking at the ability to do things like deduplication. If you start finding common blocks that are used between different volumes, that's something that we've been investigating. So it's definitely that in the block world. I think we've got a lot of capabilities there. And we've also been investigating the ability to do those kinds of things in the object and file world as well. Although to some extent the file world tends to be less performant, less concerned about performance, but more concerned about capacity, and therefore looking at using things like tape or other types of offline storage, I think is something that we want to do over time. And I think you start seeing like what we're starting to see more nearline capabilities in the cloud world, and I think that's something that we want to look to support as well.
Yeah. And then, like on top of that, two of the technologies that we're definitely investing in is our metadata services and indexing services. So for us, metadata comes in its form of, we have some unique technology called Express Query. It was developed by HP Labs. It's a very thin yet scalable metadata database, and allow you to like search metadata and tag files specifically. So you can tag a file from an end user, or a lot of people actually just do it from an app, right? So you're going to write a file out and say, let's say for like CCTV, for example, right? You say this file, it's called, whatever, some time date stamp .mov, but you can tag it with which camera it was generated from, what are the frames per second, all this kind of stuff. So you can search on the metadata and therefore be able to manage it. And then some of the key technology on indexing and search, it comes from Autonomy Idle. So Idle has the ability to index well over 1,000 different file types. And they have some really, really interesting algorithms around meaning-based search, so that if I'm a company and I want to search through all that metadata information and then index a certain type of files, I can do that. And then I say, I want to look for things that look like intellectual property, right? It sounds like a simple task, but it's actually really hard to do from a computer perspective, a database technology. So we've got some breakthrough technologies on there, and that's definitely things that we've already embedded into our products, and we're going to continue to do that in the future. So definitely metadata services, indexing and search, and then some of the things around the optimization and tiering that Sam talked about, all fitting together for efficiency and lifecycle management.
Chris, how are we on time? You in the room?
You're fine. I'm more concerned about your time at your end, but we're here. We got here late.
Patrick, you got a meeting to go to, don't you?
Yeah, I got a jam in a minute here, but if you guys have specific questions, or you want to start any dialogues on some specific things, you can hit us up on Twitter. Most of us, our email addresses are just firstname.lastname@hp.com. So feel free to give us a call, or we love talking storage. Yep.
Thank you.
Thanks,
Was
guys.
this helpful? Did this hit the mark for you guys, or
Thank you.
Yeah, we're very grateful.
Good.
It's a bit of a sardine situation back in here. I had to open the door to allow the airflow to come in. But And I didn't catch all the questions either. I'll just ask one more question, maybe, Patrick, before you. I know you have to go quickly, and maybe you touched on this, and maybe you didn't. But one of the kind of the common streams of questions we've been getting is, you know, we do. I'll take storage as an example, but I could easily replace storage with networking. So it's the whole notion around we do networking or we do storage, but there's a business driver that's driving the storage business. You know, so it kind of goes back to the question that Tim just asked about, you know, where is storage going in the future? But it's kind of like the business drivers that, as new emerging technology starts to come up, your ability to be more agile to accommodate. You talk about autonomy, for instance, brand new technology. A lot of it is unstructured data. So trying to find data out of that and then trying to store it, it almost like it poses a challenge from a storage perspective. Something that you hadn't thought about maybe 2 years ago, but now all of a sudden you're having to deal with it. So it's going back to this question of the business now starting to drive storage as opposed to storage driving the business. If that's...
Yeah, and some of the challenges too is that at the end of the day, storage is stateful and sticky, right? As opposed to being like ephemeral and portable, like on the compute side, right? So it poses a lot of problems around data that is being extremely compounded by the size of the data sets, right? So sharing data, collaborating, moving data, migrating it, mining it, all that kind of stuff is becoming very difficult. So what we're seeing is there's a lot of people doing analytics right now on, you know, trying to derive some kind of meaning from a bunch of unstructured data. In some cases it works. In some cases they don't have the algorithms or the business processes in place to do that, but they're going to save that data anyways because they see some future value of it, or they're required to save it. So we go into customers now that one of their biggest problems is storing massive amounts of unstructured data. And the cost is very high because you're at scale. Even if you're buying some of these storage products at $1 or 50 cents a gigabyte, at a petabyte, right, that's $1 million. So it can be very, very expensive. And so yeah, we're seeing that, but we're also seeing a lot of people being able to drive quicker and faster business decisions by doing things with this data. So for the example that you gave with Autonomy Idle, they have some really interesting plugins and apps that sit on top of Idle, right? So they have some tools around social media awareness where you can calculate sentiment. You've got things that can help you mitigate risk in terms of like e-discovery and searching. The example I gave was a specific customer example around intellectual property, right? They're a very well-known high-end car manufacturer, and they want to go sift through all of their files and CAD, files and all this different stuff, PowerPoints, Word, email, to find things that look like intellectual property so that they can archive them, tag them, retain them, and not lose, specific data that's important to the customer. So it's a challenge, to say the least.
What work, if any, are you doing around analytics on distributed data? So, we talk about trying to pull the data together to be able to do the analytics on it, whether it's structured data or distributed data. Are you doing any work around the analytics but not moving the data? Because it's a very different concept than what we're used to, right? You need to pull it together to be able to analyze it. But if you didn't have to move it, it would solve a lot of kind of basic block and tackling problems that we have around speed of light, that little thing called speed of light, and massive amounts of data. You just leave it where it is. Are you doing any work around that?
Idle. So the guys in Idle have a lot of what they call plugins, right? So they're trying to go out and do things at like the agent or the app level, or like unstructured data silos. You go out and talk to a filer. So that's some things there. At the end of the day, you need to have systems. If you're going to bring the compute to the storage, you have to have systems that will be able to support that. So today, kind of what we're stuck with is, a lot of these scale-out analytics platforms, for example, are very batch load oriented. You have to do ETL, get the data in, derive an answer, get the data out.
Yeah.
So,
but I think that's. Yeah. I was going to say, I think that's one of the promises of things like cloud storage and things like the object storage, is that you don't necessarily you don't necessarily do your capture, at the device maybe that created the data, but you have a global pool of storage like a cloud storage system or even a large filer like a store-all system. And it is possible, there are becoming more and more analytic engines that can work off of either cloud, off of object storage or off of file-based storage. One of the nice, particularly you see this a lot in the object storage world, where you'll actually do the compute off of the cloud, or do the compute in the cloud if you've actually got a data center built, if you've got the whole OpenStack environment.
Okay, guys, I think we've got the hook for the next session. Guys in the US, I really appreciate you coming in and spending time with us. It's been invaluable. Thank you very much.
Well, enjoy your time. It's 40 degrees here in Boston, so I hope you get to go to the beach.
Thank you.
I hear the beach in Aquadilla is beautiful. Enjoy it.
All right, nice to meet you all. Thank you.
Thank you.
Bye-bye.
Bye-bye.
All right.